My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 221. In this lecture, we will try to understand MNIST database, which has got 784 dimensions. We will try to understand a concept known as visualizing. We have to visualizing high dimensional high dimensional data. What is the dimension of this particular data set? MNIST data set, 784 dimensions. 784 dimension means it's a high dimensional data set. We will try to understand how one can visualize this high dimensional data set or database. In lecture number 206, I discussed about a data set known as IRIS dataset. This is a data set which has got 4 dimensions. This data set is basically 4-dimensional data set. Just try to recall dimensions of this particular data set is sepal length, sepal width, petal length, petal width, isn't it? Which has got 3 labels, 3 flowers. This is basically 4-dimensional data set. But if you speak strictly, this IRIS data set is not that exciting. It is not that exciting. It's not that exciting data set as it got only 4 dimensions. But in the case of MNIST database, as it has got 784 dimensions, it's little bit I can say it is little bit exciting database. Just see IRIS dataset. This is my IRIS dataset, which has got how many features, how many dimensions, sepal length, sepal width, petal length and petal width, and which has got 3 labels, isn't it? This is as I told you, this is 4-dimensional data set, whereas our MNIST data set has got 784 dimensions. In this lecture, we will try, I can say, we want to do visualization of extremely high dimensional data set, that is MNIST data set. Also, we will try to understand a concept known as dimensionality reduction. We will try to introduce this concept, dimensionality reduction. Before visualizing this 784 dimensional database, first we should reduce the dimensions. How we will try to understand this MNIST. What is this? Just see this particular page. This is a page I collected from Wikipedia, MNIST_database, wikipedia.org. What is this MNIST database? This is Modified National Institute of Standards and Technology database. Just I request you to go through this, just spend a few seconds on this Wikipedia page so that you can understand, you will get sense of this particular data set. I can say this MNIST data set, I can say it's a large data set, otherwise I can say it's a large database of handwritten digits. Just observe, this is a database. This is handwritten. All these are handwritten. 0 is handwritten digit. This 0 handwritten digit. 1 handwritten digit. 6 handwritten. 6. This is database which consists of handwritten digits. Before understanding this particular data set, let me introduce an exciting, I can say, blog. This blog name is, just say this blog name, scholar.github.io, visualizing MNIST, isn't it? It's basically, this is computer vision data set, MNIST data set. What is this computer vision data set? We will try to understand this CO, Ola. What is this? Is Christopher Ola. I can say Christopher 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 Ola. He is the person who created this particular blog. In this particular blog, he explained this particular data set in very simple manner. He also explained there are two techniques which we will discuss in our future classes. There is something like PCA. PCA means Principal Component Analysis. There is another technique, TISNE. What is this TISNE? This this is extremely popular. This one is extremely popular in mission. I can say it is extremely popular in deep learning community. I can say extremely popular. This particular technique is extremely popular in deep learning community. This PCA, Principal Component Analysis, this TISNE is useful for dimensionality reduction. This TISNE, what is this TISNE? TISNE means I can say it is T distributed stochastic stochastic neighbor embedding. Stochastic neighbor embedding. This is very important, extremely popular technique which is used to reduce the dimensionality of given data set. I will discuss in detailed manner about this particular technique in future classes. Let's look at what is this MNIST dataset. MNIST dataset is basically, as I told you, handwritten digits. This is handwritten digit. This is handwritten digit. These are, I can say, these are handwritten digits. It is. We will try to understand these handwritten digits. This is the blog, Ola's blog, Christopher Ola's blog. This is, in this blog he is explained how one can visualize this particular data set. Visualizing MNIST data set. Not only visualizing, he also explained dimensionality reduction, as this particular data set has got 784 dimensions. We can apply this TISNE technique. By using that TISNE, you can convert this particular data set into two-dimensional data set, so that you can visualize. Visualization will be simple. Visualization is simple in two dimensions. We will go to this as particular blog. As I told you, this is the Christopher Ola is a great man. He explained very neatly this particular how one can reduce this 784 dimensions into two-dimensional data set by using TISNE. How can visualize this particular data set? He explained in neat manner, in detailed manner. We will try to understand those things. Just see what is he saying. I want to understand things clearly and explain them well. That quotation itself says how great person he is. Anyway, we will try to understand this. I can say, time being, let me say that let me say I have this data set. In this data set, what I have to do, this, as I told you, this is our data set, in which you have 60,000 training data set and 10,000 testing data set. You have, let me say like this, let me take one simple digit. This is my data set. From this particular data set, let me take one digit. I can say this, you have got here, you have got this is image, isn't it? Image of particular number. This, here you have 28 pixels, here also you have 28 pixels, isn't it? 28 into 28 pixels. This size of each image is, I can say, there are 28 rows, isn't it? What's this can be represented as a matrix. Image can be represented as a matrix. There are 28 rows and 28 columns. This order of this particular matrix is 28 by 28. Therefore, how many entries one can find? As I told you, it is how many dimensions does it have? 28 into 28 means it has got 784 pixels. This particular thing can be represented as 784 pixels. Each pixel, what is this? Each pixel can be treated as a dimension. Therefore, I can say, as I told you, there are 60,000 training data points, where we have some points for 5. There are some points, you see, there are some points for 5. There are different ways of handwritten files. There are some points for 5. There are some in this particular training set. There are some points for 0. There are some points for 1. There are some points for 2. Here, let me assume I have 60,000 points for, let me say, this total data set size is 70,000. 60,000 data is for training. If you don't know about what is training, I will explain in future classes. And I have 10,000 points for testing. Time being, just understand there is a training data set as well as testing data set. If you recall your IRIS data set, as in lecture number 206, I think it is a four-dimensional data set, whereas your this one, as I told you, how many data points we are collecting here. Here I am collecting, let me say, I will rewrite your IRIS data set. What is the size? What is the dimension of IRIS data set? It is a four-dimensional data set. Why? Because how many features that this particular data set is having? Only 4 features: sepal length, sepal width, petal length, petal width. These are the column names in that particular data set. Therefore, this is four-dimensional data set. Whereas our MNIST data set, let me say D equal to xi comma yi, and your I ranges from I equal to 1 to 60k. Means there are 60,000 data points are there in this particular data set. These 60,000 points are belongs to, as I told you, otherwise let me rewrite here. As I told you, there are 60,000 points for training data set. Let me say this is let me say D equal to xi comma yi, I equal to, let me say I equal to 1 to 60k, means 60,000 training points are there. I can say this is a main image. How many? Let me say this is xi. This each xi from I equal to 1 to 60k, the x1 to x 60,000. For each xi is represented as 28 rows, and there are 28 columns. Therefore, this is 28 by this is each xi. And what about yi? Yi is class label. How many labels are there? There are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, there are 10. Here, if I write 0 here, its class label is 0. Here, if I write 1, this class label 1. There are 60,000 training data points. Each training point is associated with these labels from 0 to 9. Therefore, as I told you, 0 to our objective. What is the objective is? What is the objective of objective here? Our objective is, I can say, our objective is, let me say like this, objective is classify the written digit into one of the 10 numerics, 10 numbers, depending on this 10 one of the 10, otherwise 10 digits, I can say, isn't it? I must say x1 whether it is belongs to 0, x2 whether x1 belongs to 0 to 9, or x2 belongs to 0 to 9. There are 10 labels, isn't it? There are 60,000 training data points and 10 labels. I can say, let's just stick to 60,000 points. Now, given this image, each of our data point, if as I told you, if I keep 0, its label must be 0. If I keep 1, its label must be 1. X size needs to be data vector. This is data vector. X size needs to be, this is data vector, and your yi belongs to labels. The X size needs to be data vectors. That's column vectors. That's what we learned. We never saw images. So let me say, so the first question that comes your mind is, how do I convert an image into a column vector? if you understand, this is, let me say, this is xi, this is an image that can be image of any digit 0 to 9, as this image has got 28 rows and 28 columns. Therefore, I can say this xi has got 784 values, 784 pixel values, I can say. This is, now I must convert this into a vector. This is a matrix. What is the order of this matrix? 28 by 28. Therefore, this must be converted into a column vector. How can I convert this one into column vector? We will try to understand. It is simple and straightforward procedure. How can I analyze? Just see this. Take any digit, take any image, and it can, as I told you, it can be represented as 28 rows and 28 columns. Let's see what's interesting here. It is, let me say like this. First, before understanding, let me go to that Christopher Ola's blog. Let me show that Christopher Ola's blog. Just let me open that particular page. Just see. This is my Christopher Ola's blog. Just understand here, this is image of 1. This is 1, isn't it? This one can be represented with 28 rows and 28 columns. If it is fully dark, just see here, if it is fully dark, I will put a value 1. Just see here, 1. 1 means it is fully dark. If it is slightly gray, I will put a value between 0 and 1. That you must understand. If this is 0.1 light gray, just see, this is 0.1, this region 0.1 means light gray. 0.4, just see, this 0.4, what is this 0.4? Dark gray. This 0.7 still dark gray. 1 is full black. Just see, 1 is full black. I will show you this particular matrix in my next lecture. So that first I will try to load this particular data set, so that we will try to understand. Time being, just understand this one. 1 is full black. If it is white, just see, this portion is white. If it is white, I will put a value of 0. Just see, these zeros indicate this white portion. So we have converted now an image. This is an image into a matrix. What is the size of this matrix? 28 by 28. We have an image which is converted into numerical matrix, whose size is 28 by 28. Numerical real matrix, this matrix of size 28 by 28. Again, this matrix is not your data matrix. That you must understand. This is if there are 60,000 images, this is a matrix of one particular image. There are totally there are 60,000 images. If I assume 60,000 in training set, therefore I will get 60,000 these type of matrices. You must understand, this is one data point. This is one data point. Don't forget that. This is exactly one data point. Now the question is, since I have converted an image into a data matrix, this is an image, I am converting. How many such images are there? There are few images for zeros, there are few images for ones, there are few images for twos till 9. Totally there are 60,000 images from 0 to 9. I will get a vector. How will I get a vector corresponding to this particular matrix? It is simple. It is simple and straightforward technique. There is something like there is a technique like flattening. What is this flattening? Just let me explain this flattening. It is simple and straightforward technique. Let me say. Let me assume. How can I convert? Let me say I have a matrix of this type. Let me say like this: 1, 2, 1, 2, 3, 4. This one is, let me say, it is 5, isn't it? In similar manner, I have here also 1. I have 2, 3, 4, isn't it? 3, 4, and let me say this is 4. This is 5, isn't it? It is simple and straightforward. Just there is a technique known as row flattening and column flattening. You can make use of any one of them. Let me say this is 2, 3, 6, 7, 8, 1, 2, 7, 6, 7, 6, 5, 4, 3, some numbers, 2, 1, 7, let me assume 8, 9, 10, 11, 12, 4, 6, 7, 2, 1. Let me say like this. There is something like a technique known as, what is that technique name? Flattening. Flattening. What is this flattening? It is simple and straightforward. There are 5 rows and 5 columns. What I will do, I will take first column. What is my first column? First row. 2, 3, 6, 7, 8. What is my second row? 1, 2, 1, 2, 7, 8. In that manner, I will write first row, next second row, third row, last. In similar manner, I will write last row, 4, 6, 7, 2, 1, something like that. Therefore, what will I get here? I will get this 25. I will get a vector whose size is, there are 25 rows and 1 column. This is column vector. This is known as row flattening, isn't it? What is this? This is known as row flattening. If you want to apply column flattening, first you have to write first column, next column, second column, third column, fourth column. I must keep first column, second column, third column, fourth column, fifth column. If I do like this, I will get a column vector. I will get that is known as column flattening. Either by applying row flattening or column flattening, I will get a column. I will get a column vector. In this case, I will get 25 rows and 1 column in our data set. But in our data set, just if you go to that particular one, how that one image is represented, we are representing that one image is 28 into 28. Therefore, there are 784 entries. All those 784 entries can be flattened. Therefore, you will get a vector of size 784 by 1, either by using column flattening or row flattening. It is simple and straightforward. I can say like this. For example, in the case of our image, what is our image? Let me take any image. This image size is 28 by 28. Why? Because there are 28 rows and 28 columns. Therefore, each image can be converted into a column vector whose size is 784 by 1. Isn't it? That's the column vector. In this vector, we will have 784 rows and 1 column. So by just using row flattening, I'm able to write it is into a column vector. As I told you, you can use that one as a row. You can use either by using row flattening or by using column flattening. You can get a 784 by 1 dimensional vector. Each data point is a feature that you must understand, isn't it? For example, let me say my data matrix. Let me say like this. Let me write like this. This is how many? This is how many features? I have 784 features. How am I getting these 784 features? Let me say this is my data matrix. This is my training matrix. How many elements? How many training points are there? There are 6. Let me assume there are 60,000 training points. 1, 2, 3, so on. Let me say 60k. First training point. First training 1 to 60,000 training points. Therefore, your xi, let me say your xi belongs to R784. R784. Why? Because your xi is a column vector whose how many rows are there? There are 784 rows and 1 column. 784 rows and 1 column. That is my xi, isn't it? x1, x2. But if I write xi transpose, what is this? xi transpose. If I write something like xi transpose, I will get column vector with this will converted like this. How many pixel values you will get here? You will get 1, 2, 3, 4, still 784 pixel values you will get. Each pixel value I am treating here F1, F2, F3, so on. I am treating each pixel value as a feature. Therefore, how many features you will get? This is first vector with 784 features. Second vector 785 features. How many vectors you will get? You will get 60,000 vectors for each point. For each point, I will get a row vector. Xi is a column vector. Xi transpose means row vector. For each xi, I will have a yi. Yi belongs to, it is 0, 1, 2, so on, 9. Isn't it? There are 9 labels. Isn't it? It is simple. We have 784 dimensional data set. We struggled, try to recall, we struggled even to visualize 4-dimensional data set. It's difficult to visualize 4-dimensional data set. When we have 4 or 5 or 6 dimensions, we use things like pair plus, 4 dimensions, 5 dimensions, 6 dimensions. We use something like pair, just try to recall pair plots, isn't it? We use pair plots, but with pair plots also. But as soon as the dimensionality increases, as soon as dimensionality increases, even dimensionality increases, even it becomes pair plots becomes almost useless. That you must understand. Pair plots becomes almost useless. When will it be almost useless? In which case they are useless? If you have more number of dimensions, as this particular data set has got, but in the case of iris data set, sepal length, sepal width, petal length, petal width, you have only 4 dimensions. But here you have each pixel is treated as a dimension. Therefore, it has got 784 dimensions. Visualizing these 784 dimensions with pair plus, it's almost useless. Now here is the most interesting thing. How do we now visualize a 784 dimensional data set? That's important. How can I visualize this 784 dimensional data set? This is the beauty of machine learning. We will use simple linear algebra, a very simple idea to visualize this 784 dimensional data set. Before we go and learn techniques like PCA, as I told you, before we learn, I will explain this PCA and TISNE. These are the techniques which are useful for dimensionality reductions. I want to show you a result which are mesmerizing. Just let me show the results. Let me go to this Ola's blog. As I told you, this is a wonderful blog which explains this dimensionality reduction in simple and straightforward manner. Just see this particular output. Just see this one. Yes, 1 minute. Just see this one. This is each point. Just see, these are the points. These are the digits 0 to 9. First you must understand each dot. There are, just see, these are the dots. Each dot represents a data point. This is 8. This is a data point related to 8. This is a data point related to 0. This is a data point related to. Each data point represents a 784 dimensional data point. Of course, we can't visualize these 784 dimensions. We can't visualize these 784 dimensions. We are projecting these 784 dimensions into 2 dimensions. My x-axis here, on x-axis I am taking dimension 1, on y-axis I am taking dimension 2. So what I have done, I have taken a data with 784 dimensions and I have converted this into a two-dimensional data. So this 784 dimensions is converted into dimension 1 along x-axis, dimension 2 along y-axis. This 784 dimensions is converted into 2-dimensional set by using a technique known as TISNE. I will discuss about this TISNE in future classes after few classes. Timing, just try to be patient. I have taken 784 dimensional data and transformed this using an algorithm known as TISNE. This we will learn what is we will try to understand. We will try to understand what is this TISNE. As I told you, as I am repeatedly saying, I will explain this TISNE technique after a few classes. We converted the 784 dimensions into 2-dimensional data set and we have given the color code. Just see, we have assigned color code. Let me show this to you. Let me show this with an let me play this one so that you can understand this output. Just see how beautiful this output is. Just if you observe carefully, we have given color code, isn't it? Let me show. So I'm just going on this page. My red point where let me say where there are zeros, isn't it? There are zeros, there are ones. Just see, this indicates 3, isn't it? Just see this red point. Just see, red points are zeros, isn't it? These red points are zeros. Just observe, these red points are zeros. You notice. So what about your these points after zeros? Just see, this one is something like this. This might just we have blue points. What about this blue points? Very much. Just see, this red is 0. What about this blue point? Just blue points are 6, isn't it? That blue points are 6. As I told you, we have given color coding. Blues are 6. You are what about 3? Just see, this one is this. This one is, yes. This I can say dark green is 3. Your I can say we have given different colors, isn't it? Just see, what about this is number 3 indicate, this is number 2. Where is this number 1? Just see, this is number 2. This is yes. We are giving different colors for different numbers. They have what we did here. They applied Tisney techniques to transform this 784 dimensional data into two-dimensional data, and they have given color code. They all just see, all zeros are grouped together. Just see, all zeros are grouped together. All ones are grouped together. Just see, all ones are your browns are ones, isn't it? All the fives are grouped together, isn't it? All fives are grouped together. Something like this. This is the dimensionality reduction. What I'm taking a data which is extremely high dimension, I'm converting into a very low dimensional space, and now when I visualize this data and when I color these points based on YAs, based on their labels, it looks very logical. All my zeros are somewhere. Where are my zeros? Just see, all my zeros are somewhere here. All my sixes. Where is my six? Just see, all my sixes are mostly here. And isn't it? They give me a lot. So this gives me a lot of intuition on how the data is in the 784 dimensional space. So this is the final outcome after running Tisney. But what happens internally? We will try to understand internal things. I will explain what was this Tisney after, as I told you, after a few classes. So this MNIST database, which will use for dimensionality reduction from 784 dimensions to 2-dimension techniques, we will run through all of them. We will replicate these results. We will try to understand these Tisney technique, as I told you many times, isn't it? This Christopher Ola, he's created a beautiful output. Just he used, I think he used JavaScript. But as I told you, I will discuss about this particular output in detailed manner as I am discussing repeatedly. Our 784 dimensional data set is converted into 2-dimensional data set. Not only converted into 2-dimensional data set, after that we are visualizing. Just see, we are visualizing numbers. Isn't it? Just what I did here, what we are doing here, we have a data set known as MNIST dataset. In this MNIST dataset, it is a dataset which consists of 0 to 9. There are 10 digits. There are 10 labels. We have image of each digit. How many such images are there? There are 60,000 images for training data set, 10,000 on testing. What is training and what is testing, I will explain. Each image is represented as a column vector, and if I say XI transport, you will get a row vector. Each pixel value is a feature. There are 784 pixels for each image. Therefore, each pixel is treated as a feature. Each pixel is treated as a feature. There are 784 features and 60,000 points. This is this capital X, I can say it's a data matrix. Single row is a single data point. We will try to understand how to load this particular MNIST data set in my next lecture, that is in lecture number 222. Thank you very much.